The paper of the day is WebTables, Exploring the Power of Tables on the Web. WebTables is a project to extract and process HTML tables from Google's search index. It attempts to answer two questions. What are some effective techniques for searching structured data at search engine scale? And what can be derived from analyzing a large corpus of HTML tables? Web documents often contain structured and relational data embedded in HTML tables. The WebTables project extracted 14.1 billion English language HTML tables and further filtered those down to 154 million tables that contain structured data. From this data, we have the potential to determine semantic information embedded in the web, create visualizations, and integrate web documents into new applications. By viewing HTML tables as small relational tables, we discover the problem of effectively exposing this data to search engine users. This requires ranking billions of small relational tables that each contain their own schema and set of tables and matching rank tables to user input. Modeling tables. So the authors wrote a system for automatically extracting tables from web documents. This use of a combination of handwritten and statistically trained classifiers for filter good results from bad ones. The actual extraction algorithm is the subject of different paper and not described here. For the remainder of the paper, you can assume a corpus R of relations that are extracted from HTML documents. Attribute correlation statistics. To rank HTML tables according to search criteria requires scoring the data using an algorithm tailored to table-based data. The authors compute some summary statistic called the Attribute Correlation Statistic Database, or ACSDB, for this task. These statistics allow for the calculation of the probability of seeing attributes within a given table schema. For example, P address is simply the sum of all counts C for pairs whose schema contains address divided by the total number of all counts. The statistic also allows us to detect relationships between attribute names. For example, P address given name returns the probability of having an attribute address in a relation given that the attribute name exists. Modeling tables. Continuing, the WebTable search engine uses the data model embedded in the ACSDB statistic to allow users to rank relations by relevance of a query using a familiar keyword-based input. The authors use this data to derive several ranking algorithms, combine them using a linear regression estimator scored by human judges. Some algorithms operate solely on word data and return results similar to the text-based search. Other algorithms take advantage of the table schema. The best performing algorithm is the schema rank. This ranking scheme uses features of the table such as number of rows, number of columns, hits on the header values, hits on the table body values, combined a schema coherency score derived from ACSDB. Intuitively, the schema coherency score ranks tables based on how closely related the table's attributes are one to another. Applications of the ACSDB. Having the data embedded in the ACSDB allows for a few novel applications. First, the ACSDB allows for a schema auto-completion and can be used to assist database users that are designing a database system. The autocomplete system can guess appropriate attribute names based on the previous data points. A second application of the ACSDB is in suggestion attribute synonyms. This can help users find column headers that are synonyms of one another. This can also be used to help return valid search results. Lastly, the database can be used to artificially join relations in a join graph. That is, related relations can be returned based on the schema information present in the search results. The authors present experimental results for each of these applications, proving the usefulness of the ACSDB as a statistical measure for the relation table data. Looking at the contributions, by extracting a search engine scale sample of HTML tables from web documents, the authors were able to derive statistical ACSDB. The ACSDB can be used for some novel applications in search engine technology. This paper shows the value of using statistical analysis on large data sets and provides some exploratory work in realizing the semantic information embedded in the web.